Right now we have sine to the power of 10x times cosine cubed of x, and we need to integrate this. So what we want to do is convert everything to one of the trig functions. We want everything in sine or everything in cosine with only one term being the opposite. For example, we would want sine to the power of 10x times cos x. We don't want cos cubed x. So that's because we're going to use substitution. So how can we rearrange this so that we can have everything in terms of one function, leaving only one term of the other function? Well, we know that sine squared x plus cos squared x is equal to 1, and this is from the Pythagorean theorem on our unit circle. So we can write this cos cubed x as 1 minus sine squared x. So let's do that. So sine x to the power of 10 times cos squared x. So we can write cos squared x as 1 minus sine squared x. And we still have 1 cos x left over from our cos cubed x. And right now we have everything in terms of sine except for 1 cos x. So this will allow us to use our integration by substitution. So if we continue to simplify this, then what we're going to get is sine x to the power of 10 minus sine x to the power of 12 times cosine x dx is going to be our integral. So now if we let u equal sine x, then du is going to perfectly be cos x dx. So it's a perfect substitution. So u is sine x and du is going to be cosine x dx. So if we write this in terms of our new variable u that we substituted, what we're going to get is u to the power of 10 minus u to the power of 12. And now notice that our goal, which is to write x in terms of u, has succeeded because now we can replace cos x dx with du. So we have our integral now in terms of u. So now we can just anti-differentiate this. So u to the 10, we just do 1 over 11 u to the 11 minus the antiderivative of u to the 12 is 1 over 13 u to the 13th plus c. And finally, we have to substitute sine x for u because our original integral was in terms of x. So we have 1 over 11 sine x to the power of 11 minus 1 over 13 sine x to the power of 13 and plus c.